In this tutorial, we're going to design the flexible pavement structure for the urbanism. The roads of an urbanism are considered as a low-volume traffic road structures because isn't expected to convey a significant level of truck traffic. The urbanism is on field ground with a CBR of 10%, which represents the roadbed. The design is based on the section 4.2.1 of the AASHTO guide for design pavement structures to the low traffic volume by picking the recommended structural number on the table 4.7 in accordance with the features of the site and expected traffic volume. From that table, we have to define the region, the relative quality of the roadbed soil and the traffic level. The climatic characteristic of the region are wet and no-freeze, which is region 1 in accordance with the figure 4.1. The relative quality of the roadbed soil lies in its capacity to drain the rainfall water, which according with the soil analysis is fair to good, which means that the time to drain the rainfall is between 1 day and 1 week. The traffic level has been measured in accordance with the Appendix D of the AASHTO guide through the analysis of the traffic expected for the urbanism, which is summarized in this table, where W is the weight of the vehicles in accordance with the Federal Highway Association HRT 13-091. QYT is the quantity of vehicles of each class. Growth is the traffic growth factor calculated with the table D20 of the Appendix D for a 20 years analysis period and a growth rate of 4%. Traffic is the applications in 1 year, and the ESAL factor was obtained from the table D1 of the Appendix D of the AASHTO guide for serviceability of 2% for flexible pavement in accordance with the section 2.2.1 of the AASHTO guide, giving a result of 60,000 applications, which categorizes the traffic level as low, in accordance with the section 4.2.1 of the AASHTO guide for design pavement structures. The structural number recommended, taking the worst condition, is 2.7. With the structural number already defined, we proceed to calculate the thickness of each layer that compose the roadway, in accordance with the equation of the section 3.1.4 of the AASHTO guide for design pavement structures. The material selected for each layer was chosen after a local study of the different quarries that are near to the site, in accordance to a cost-quality approach, where A1 is the layer coefficient of the asphaltic concrete course and is calculated with the figure 2.5, which, in accordance with the technical sheet, its elastic modulus is 350,000 pounds square inch, giving a result of 0.39. A2 is the layer coefficient of the base and is calculated with the figure 2.6, which in accordance with the technical sheet its CVR is 65%, giving a result of 0.128. And A3 is the layer coefficient of the subbase and is calculated with the figure 2.7, which in accordance with the technical sheet its CVR is 27%, giving a result of 0.105. D1, D2, and D3 are the thickness of the asphalt base and subbase layer respectively, and N1 and N2 are the drainage coefficient for the base and subbase layer respectively, and are calculated with the table 2.4 of the AASHTO guide for design pavement structures. For material with a drainage quality qualification as good and time exposed to saturation between 1 and 5%, its value is 1.2. Applying the procedure of the figure 3.2 of the AASHTO guide for design pavement structures, first we fix the thickness of the asphalt layer to calculate the structural number required for the asphalt course, in accordance with the table of the section 3.1.4 of the AASHTO guide, based on the minimum thickness required for a traffic level, which is 2 inches. We will fix it in 3 inches. The structural number SN1 is 1.17. Now we calculate the thickness required for the base layer with this equation, where Sn2 is a value assumed for the structural number of the base layer plus the structural number before calculated. The value assumed is 0.615, giving a base thickness of 4 inches. And finally, the thickness of the subbase layer is calculated with this equation, where Sn3 is the structural number required for the wall structure, which is 2.7 minus Sn2, giving a subbase thickness of 7.26 inches. In this figure, we can observe the final layer thickness of the asphalt base and subbase of the roadway. And in this figure, we can observe a complete section where is shown the elevation of each element that compose the project. With this, conclude this tutorial.